Hi, Chris Kuzmal here. We're going to talk about compactness. What we're going to conclude with is that compactness corresponds to our capacity in relational logic to take even an infinitely large set of logical sentences and break it into two, one of which is of finite extent and which is unsatisfiable. So if we start off with something that's like this red bar across the top, which represents an infinite set of sentences, we can break off a finite subset that is unsatisfiable, assuming the infinite set is unsatisfiable. There, of course, is going to be an infinite subset as well that's still left, and it may or may not be unsatisfiable, and that's represented by the yellow bar that goes off to the end to the right. This is sort of set up by some things that are almost obvious, but we need to point them out because we're trying to be rigorous. And that is that in relational logic, we have a few fundamental entailment rules, and that is that a particular relation entails the disjunction of that relation with another, but it does not entail the conjunction of that relation with another. We're fundamentally defining and or here, or reasserting and or for relational logic. And also, if we have two relations in a set of logical sentences, then we can infer that does entail the conjunction of those logical sentences. Um, Also, we can reverse the order of our variables, and that's because a relational logical sentence with free variables can be replaced by the same sentence where those free variables are replaced by universally quantified variables, and we've already established common quantifier reversal. Okay. Um, and more generally, we can convert from relational logic to propositional logic using this lovely formula, which fundamentally pushes all the quantifiers to the left, grounds the logical sentence that we have then, and then renames relations to be propositional constants. And so that means that since we have equivalence between relational logic and propositional logic, relational logic is compact. And that means that even if we have an infinite set of sentences that are unsatisfiable, to prove that they are unsatisfiable, there is some finite set that we can break off and just show that it is unsatisfiable. We always know that that finite set is there somewhere when we have compactness. And so that's what we're saying here as well. And so although we said it, what does it even mean? And this brings us back full circle to our original diagram, which is we can always take that infinite set and break it into two. And this is sort of the only thing that I'm really hoping for you to remain with. I've stated a number of things about relational logic here that are so intuitively obvious. I think it's harder for people to recognize that they could possibly not be true or possibly not apply. But as I said, in logic, we try to state even the obvious. And amazingly, even once we stated the obvious, we get some pretty amazing results as well, such as this. Don't feel that we've proven compactness formally here, but we have identified that compactness is a property of relational logic.